So in this video, we're going to talk about different ways to charge objects and what it means to ground objects. But first, let's do a little review of last video, and we're going to do a musical review. This is a song I wrote maybe about 10 years ago, and it's fitting for this topic.
Another nucleus is back within our cloud. Protons and neutrons, this is where they're found. Ernest Rutherford and his gold foil. Nature's secret, this is what he spoiled. It was something unexpected, but in the end it's right. The nucleus was quite a sight. Atomic number of protons, it explains how the neutron's atomic mass is playing. One more thing, the electrons in the cloud. J.G. Thomson, they made him so proud. Protons and electrons, equal they must be. The atom is neutral, you see. Something unexpected, but in the end it's right. The nucleus was quite a sight.
Way I can charge an object is charging by friction. So we'll do this in class, but this is just rubbing a rubber rod onto cat for now. There's something called the triboelectric series. So this is, and you don't have to memorize this, but you might want to put it on your equation sheet. This is a list of how well substances grab electrons from other substances, right? So from the song, we see that all the atoms and all the substances in the world are neutral. By nature, they have the same number of electrons as they do protons. But if I rub two different substances together, one substance is better at taking electrons than the other. So the higher you are in the triboelectric series, the better you are at grabbing electrons, right? So if I rub rubber on rabbit fur, the rubber will get the electrons. If I rub glass on rabbit fur, the glass will get electrons, right? However, if I do silk on glass, then the silk gets the electrons, and the glass would lose the electrons. So this is one way we can understand charging by friction, which is just rubbing two objects together. Right, rubbing your hair on the balloon. Your hair you can think of as rabbit fur, and rubber is the balloon, so the balloon gets the electrons. So that's how charging by friction works. Let's try a few questions, and you can pause the video here and think about these, but here's question one. During a physics lab, a plastic strip was rubbed with cotton, became positively charged. The correct explanation for why the plastic strip becomes positively charged is, it gives some choices. And then the second question, so take a minute, pause the video, think about it, and see if you can get the right answer. So for the first one, the answer is actually D, right? We can eliminate a couple of the answers here. The plastic strip acquired extra protons from the cotton. Remember, in charging, it's never the protons that move. It's always the electrons. The protons stay put. B, the plastic strip acquired extra protons during the charging. Again, protons, we're not changing protons ever. And then C, Protons were created, so it's not that one, so it's D. So the plastic strip lost electrons to cotton. Now, plastic isn't on here, but cotton is. Cotton is right here. It's pretty high on the triboelectric series. So we suspect plastic would have to be somewhere down here because cotton was able to take the electrons from the plastic. For this one, the correct answer is saran wrap. Saran wrap is this celluloid. It's so anything that's kind of a thin, plasticky, flexible material like that. So saran wrap is higher on the list than nylon. So it would acquire the extra negative charges. Nylon would become positively charged. All right, and so one last one here. Take a second and pause the video. Go ahead and read the question, and then we'll talk about the right answers here. Okay, the correct answers, the ones that are true, are B, D, and G. Why is A incorrect? Again, objects never gain or lose protons when they're getting charged. So the glass becoming positively charged isn't because it gained protons. The felt became charged negatively. Well, if we know the glass becomes positive charge, the felt then must have gained the electron, so it must be negative charge. C, again, charge is created. Charge is never created. It's just shared between objects. D, if the glass acquired a charge of plus 5 units, the felt acquires of charges minus 5 units. That's true. If you remember from video 1, we say charge is conserved, and this is again showing that charge is conserved. E, this event violates the law of conservation. No, we just said that it is conserved. F, electrons are transferred from glass to felt. Protons are transferred from felt to glass. Protons are never transferred, so it's not that one. G, once charged in this matter, the glass object and the felt should attract each other. That is true, since they are opposite charges. And H, in general, glass materials must have a higher affinity for electrons. Well, remember, the glass became positively charged. So if it's positively charged, it's lost electrons. It has a lower affinity, okay? So that's how you do charging by friction. All right, the next method of charging is called charging by induction. So let's first take a look at what happens here. So imagine I have two of the metal spheres that you've seen in class, right? We've done some demos with these. And so these are conductors. So in a conductor, right, electrons can move anywhere they want. So if I bring a negative balloon, a negatively charged balloon, close to this first sphere, well, you can imagine the electrons, they all move to one side. So even the electrons here move over to B to get away from it. If I then separate the spheres, now this negative charge can't get back to where it started. And so what we have is a net loss of electrons in sphere A, a net gain of electrons in sphere B. So this becomes positively charged, this becomes negatively charged. And again, you see A loses 5 of its electrons, and it has 5 positive charges, right? Because that's 5 protons that don't have electrons, right? So this is the idea of charging by induction. We can again see charging by induction here with Coca-Cola cans. And this is just another way to kind of visualize it. But here, the negative balloon brought close to the Coca-Cola cans. The electrons from this can scooch over here to get away from the negative charge there, and then we separate. Aha! We've trapped you, you electrons, and now they're stuck on the other Coke can, so we've charged both cans, and this is called charging by induction. Now, it is possible to charge a sphere, or to charge an object, a single sphere by induction, but first, you have to understand the process of grounding. So let's look at an object that has a net negative charge. If I were to touch it with my fingers, this is called the process of grounding. My fingers give a path for all the extra electrons to come into to come into my body and eventually to the ground, which is why it's called grounding. So this is the process of grounding for a negatively charged object to make it neutral. A positively charged object can also be grounded. So take a look at this. This object has a net positive charge. So if I touch it with my finger, electrons come from my hand into the object, right? So here's a positively charged object. I touch it with my fingers. Electrons travel through me into the object to balance out charges. So both ways, grounding can neutralize the charge of an object. And so if I have a single sphere, I bring a balloon close to it, I draw the electrons towards the positive charge. The positive charge here is on this side. I touch my finger to it. Electrons move through me to this side. And now we have a net negative charge because I've added electrons to the sphere. So the sphere is now negatively charged. So let's take it for a spin with some test questions. All right, so go ahead and pause the video, read through this, and let's see if you can get the right answer. All right, so let's see if you got the process down here. The right answer for this one is actually C. So let's talk about this. When the balloon with a positive charge here is brought near to can X, right, the electrons move this way. And so this can gets extra negative charges. This can has positive charges. So here's our negative can and our positive can. And if we left it at this situation, this can would be negative and this can would be positive. And if you put negative, I see why you put it. But when I bring the cans together without the balloon being there, the extra negative charges can zoom back over to meet the extra positive charges, right? So the electrons move back from whence they came, and both cans end up having the same number of positive and negative charges again, just like they started with, and they become neutral. All right, so a little trick, but let's do another one. All right, so here's your question. Take it for a test drive. Let me know how you do. Okay, there's actually only one right answer for this, and it's G. None of these occur. Let's talk about this. So when I bring this close to can X, do electrons jump from the glass rod to can X? Well, no, the electrons aren't going to jump through air, so it's not A. B, electrons jumping again. Nothing with electrons jumping. Nothing with protons jumping. Protons don't move, so it can't be any of these. So the right answer is G. All right, and one last one. Go ahead and pause the video one more time and give this a shot. All right, so if you look at this one, when I bring the positively charged balloon close, right, we're going to get polarization, right? We're going to get charge separation. We're going to get negative charges here and then positive charge here. Oh, let's make that a little bit bigger so it's easy to see. So on this side, let's get rid of that. We're going to have negative charges here and then positive charges here, right? So now when I bring my finger close to this, I'm going to get grounding, but this electrons are going to come from my hand. So electrons are going to move into the sphere from my hand or from the ground. So they're going to move this way. So the right answer is A for this one. Charging by conduction is our third way of charging an object. It's very easy to understand. I have a negative rod. I bring it close to a neutral conducting sphere. It doesn't have to be conducting. It can be a rubber sphere. But if it's a conductor, the electrons are free to move. Anyways, I bring this rod and touch it to this neutral object, and some of the electrons from the rod will go on to the sphere. And in charging by conduction, both objects end with the same charge. A lot of people make the mistake and think, oh, the extra electrons, right? This says these electrons are just the extra electrons. It has lots of protons and lots of other electrons, but these are the extra ones that give it its charge. It's not all of the extra electrons move on. Some of them do, giving this one extra electrons, but this one still has extra electrons too, so they both have the same charge. So let's try this one out for size. So neutral, so go ahead and read the two questions and see if you can get the right answer. For number one, the right answer is B for both of them. Remember that the rod will still be negatively charged after charging by conduction, and so will the sphere. So they will both become negatively charged. How about 2? So the right answer for 2 is C. So I hope that was fun. If you have any questions, bring them to class. Okay, I got a charge out on that video. Hope you did too. Talk to you next class, and have fun.